Shri Sairam. In the previous class, we solved problems from exercise 8.4, and today we are going to solve some more example from exercise 8.4, and also we have to discuss the square root of a complex number. Let us solve a few examples from 8.4. Here we have to verify this using the given complex number. This is distributive law of multiplication over addition. So let us verify that. Here if I take LHS is Z1 into for Z2 plus Z3 is equal to Z1. What is Z1? 4 plus 3i into Z2. Z2 is 3 minus 2i plus Z3 is I plus 5. So this is equal to 4 plus 3i into 3 minus 2i plus I plus 5, which is equal to 4 plus 3i into here 3 plus 5 is 8, and here minus 2i plus I is minus I. Now you multiply this, it will be 4 3s are 32 minus 4i plus 24i, and this is minus 3i square. So this is equal to 32 here minus 4i plus 28i will be 20i minus 4i plus 24i is 20i, and here minus 3i square. If you take my I square as minus 1, it will be plus 3. So now this is equal to 32 plus 5, 32 plus 3 will be 35, and here we have 20i. Did you understand? Minus 4i plus 24i will be 20i, and 32, and this is minus 1. I square value is minus 1. Minus 1 into minus 3 will be plus 3. 3 plus 32 is 35, and minus 4i plus 24i is plus 20, and here the LHS is 35 plus 20i. Similarly, you take RHS. What is RHS? Which is Z1 into Z2 plus Z1 into Z3. So which is equal to, what is Z1? And Z1 is 4 plus 3i into Z2 is 3 minus 2i plus Z1 is 4 plus 3i, and Z3 is I plus 5. So you just multiply and simplify this, which is equal to 4 3s are 12 and 8i plus 9i minus 6i square plus this one 4i 4 5s are, and this 3i square plus 15i, which is equal to here 12 and this will be plus 6, and here minus 8 and this will be I plus 4i 15i will be 19i plus 20 minus 3, which is equal to 12 plus 6 will be 18 plus I plus 19 plus this is 17. So which is equal to 18 plus I plus 19, this is 19i plus 17. So you just add it, 18 plus 17 is 35 plus I plus 19i is 20i. So you look at RHS as well as LHS, both are equal. Hence we can say that, hence we verified that Z1 in of Z2 plus Z3 is equal to Z1 into Z2 plus Z1 into Z3, as both values are equal there. Okay, 35 plus 20i, here also LHS is 35 plus 20i. Next we have another problem, similar problem. which is z1 is 2 plus I, and z2 is minus 2 plus I, and z3 is 2 minus I. And we have to verify that z1 into z2 of z3 is equal to z1 into z2 into z3. This is what we have to verify. In similar way, we have to do it. This is like a, if I take LHS is z1 into z2 into z3 is equal to, what is z1? z1 is 2 plus I into z2 is minus 2 plus I into z3. What is z3? 2 minus I. z1 2 plus I, z2 is minus 2 plus I, and z3 is 2 minus I. So here you multiply this 2 minus 4, and this is plus 2I minus 2I and plus I square. Listen to 2 into minus 2 is minus 4, and 2 into I is 2I, plus plus I into minus 2I is minus 2I, and this plus I into plus I is I square into 2 minus I, which is equal to, here plus 2I and minus 2I get cancel each other, and you will have minus 4 minus 1. Since I square is minus 1, so you will have minus 4 minus 1 into 2 minus I, which is equal to, this is minus 5 into 2 minus I, which is equal to minus 10 plus 5I. As you multiply minus 5 to this, minus 10, and which is, this is LHS. Similarly, RHS, if you consider, RHS is Z1 into Z2 into Z3, which is equal to, Z1 is 2 plus I here, and Z2 is minus 2 plus I, and Z3 is 2 minus I, which is equal to 2 plus I. What is this? You multiply minus 4, this is plus 2I, and this is minus 2, this one, and it will be I into 2 is 2I, and minus I square here, so which is equal to, so minus 4, and you will get minus into minus get plus, and it will be plus 2I, and if you multiply this one, I into 2 is 2I, and plus I into minus I is minus I square, so which is equal to 2 plus I into this one, see, minus 4, this one is 4I, and this is, if you must substitute I square is equal to minus 1, it will get be plus 1, which is equal to 2 plus I, this is minus 3 plus 4I, and which is equal to 2 plus I into minus 3 plus 4I. If you multiply this, it will be equal to minus 6 plus 8I, and minus 3I, and plus 4I square, so which is equal to minus 6, and this will be minus 4. As I substitute I square is equal to minus 1, minus 1 into 4 will be minus 4, and here plus 8I and minus 3I, suppose which is equal to minus 10, and plus 8 minus 3 will be plus 5I. So you may look at both LHS as well as RHS. So as LHS is equal to RHS, both the numbers are equal. Therefore, LHS is equal to RHS. Hence, we verified that. Thus, we verified that Z1 into Z2 into Z3 is equal to Z1 of Z2 into Z3. Hence, we have verified. Okay. Next, we will start that square root of a complex number. Here, a plus ib is a complex number, and x plus iy is its square root. That is, square root of a plus ib will be equal to some other number, say x plus iy. We will find what is x and what is y. So if I make it square root on both sides, if I take squaring on both sides, if I take squaring on both sides, okay, what you will get is if you make it square, the root will get cancelled and this become x plus iy whole square. What is x plus iy whole square? X plus iy whole square is equal to x square plus iy whole square plus 2i, let it be I 2xy. Okay, so this is x square and iy whole square become minus y square, as I square is equal to minus 1, and this is I 2xy or 2ixy. Okay, here you can see the equality of two complex number. We can equate real part is equal to real part and imaginary part equal to imaginary part on either side of the equation. So that if you equate, so you will get x square minus a square will be equal to a, and 2xy is equal to b. That I will call it as equation 2 and this is equation 1. Next, yeah, see, I can write x square plus y square whole square as x square minus y square whole square plus 4x square y square. You remember that x square minus y square is equal to what is that in the previous slide? X square minus y square is equal to a, that is equation 1, and 2xy is equal to b. See in the previous slide, that is equation 1, x square minus y square is equal to a and 2xy is equal to b, and that is what we have called it 1 and 2. This is important equations. So now I can write x square plus y square as that equation 3, and if I write, see, x square plus y square, here x square minus y square is what? A, and its square becomes a square plus here 4x square y square. If you squaring on both sides of equation 2, you will get 4x square y square, then that gives b square. I have substituted here. And if you take square root on both sides, you will get x square plus y square is equal to square root of a square plus b square. And if you from equation 1 and 3, we can able to write that what is that 2x square is equal to square root of a square plus b square, which is plus a, which implies that x is equal to plus or minus square root of 1 by 2 into square root of a square plus b square plus a. And similarly 2y square is can be written as square root of a square plus b square minus a, which is equal to y is equal to, if you take it square root on both sides, you will get y is equal to plus or minus square root of 1 by 2 square root of a square plus b square minus a. Here we have used both equation 1 and 3. What is equation 1? This is x square minus y square is equal to a, and equation 3 is, what is equation 3? X square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. This is equation 3. We have used that both equation this 1 and 3. Listen to it. So you will get 2x square y square is equal to this thing square root of a square plus b square plus a, and if you arrange it for x, you will get plus or minus square root of 1 by 2 into square root of a square plus a. Similarly for y also. So here what we have done is we have rearranged it. So that is if x square is equal to what? A plus y square, and y square we have rearranged it from equation 3 as well. So you will get that. So here we have 4 pair of values are there for both x and y. We have for x we have 2 values, for y we have 2 values, and if see here we have to discuss either in from equation 2, which is equation 1 is what is x square minus y square is equal to a, and equation 2 is 2xy is equal to b. Okay, this is equation 2. From equation 2, we have to discuss, suppose b is positive, the product is positive. Okay, what are the possible values for x and y? And another case is if b is negative, what are the possible values of x and y? That is what we have to discuss it now. This is the formula to find square root of this complex number. Yeah, see, Yes, just now we have discussed that. So we have to take the values of x and y in such a way that it should be satisfies equation 1 and 2. So now if I take b is positive, see if I take b is positive, you will get both x and y of the same signs. Okay, in that case, if b is positive, you will get both x and y are of same signs. Either it is plus or it is minus. Next, another case is if b is negative. If b is negative, you will get the alternative sign for x and y. Okay, so that is here. If b is negative, you will get minus x. That is, if you get minus x, then it will be plus y. You will get the value of y. The sign of y will be positive. Okay, that is plus. You will get it. Other case, in other way also, it will be either plus x minus y, like that you will get it. So the sign of x and y will get altered. Okay, see like this. If it is negative, here y is positive. If y is negative, x is positive. Hence, a plus ib has two square roots in each case, and the two square roots just differ the signs. Understand? Let us solve one example, then you will get a clear picture of finding square root of a complex number. Here I have a complex number which is 7 plus 24i, and square root of 7 plus 24i will be equal to some complex number, say x plus iy. I call it as equation 1. Similarly, just we have solved that previous this generalized complex number, right? In the same way we can do it this also. So here, if I take squaring on both sides, you will get 7 plus 24i is equal to x square minus y square plus 2ixy. And if you compare the both real and imaginary parts, you will have x square minus y square is equal to 7 and 2xy is equal to 24, or xy is equal to 12 if I divide 2 on both sides of this. Next, you will have, if I write x square plus y square whole square is equal to, I can write x square minus y square whole square plus 4x square y square. And here you know that what is x square minus y square? X square minus y square is 7 and its square become 49. And here we have 4x square y square. So if you multiply this, if you make it square, x square y square is equal to 12 square, which will become 144, and 4 is here. Yes, if you make it square, x square plus y square whole square becomes 625, and if you take square root on both sides, it will become say square root of 625 will be 25. And if you solve equation 2 and 4, you will have 2x square is equal to 32 and x will become plus or minus 4. And similarly 2y square is equal to 18 and y will be equal to plus or minus 3. From equation 3, what is that? We have written xy is equal to 12, which is see here, this is important observation. So while finding square root of a complex number, this is an important observation. The product is positive, that means the b is positive, as we discussed in the previous. So b is positive means both x and y will get the same signs. Understand? So x and y should be of same signs. So therefore, if I take x equal to 4 and y is equal to 4, or x equal to minus 4 and y is equal to minus 3, and you will have, hence we can write the square root of the given complex number as 4 plus 3i or minus 4 minus 3i. See, and we can solve this in other way also. See, the given complex number is 7 plus 24i. 7 plus 24i. So what is equation 1? See, equation 2 is x square minus y square is equal to 7, okay? X square minus y square is equal to 7. This is equation 2. And another equation is xy is equal to 12, which is positive. Here the product is the product is 12. Okay, that is positive one. Either, so you remember the factorization, either 3 into 4 is equal to 12, and this, the value of x and y should satisfy this one, that is x square minus y square is equal to 7. So in such a way you have to choose the values of x and y. If I take 3 and 4, for example, 3 into 4 is equal to 12, understand, and if you put the same value for x and y here, it doesn't satisfy, right? So because 3 square minus 4 square, you will get the negative. Therefore what I can do is, I can consider 4 into 3. 4 into 3 is also equal to 12. That is, we are taking both x and y as plus 4 and plus 3. See, if I substitute that, 4 square minus 3 square is equal to 7, obviously 4 square is 16 minus 9, which is equal to 7. Hence, I can take x equal to 4 and y is equal to 3, positive values. In other way also, I can take x equal to minus 4 into y is equal to minus 3, which is also equal to 12. And you can substitute this x equal to minus 4 and y is equal to minus 3 in this equation, that is in this equation. You will get, that equation will be satisfied. Therefore, we can say that there are two complex numbers. The square root of a given complex number are 4 plus 3i or minus 4 minus 3i. In that way also we can able to find the square root of a complex number. Next, this is something like you will get the product as negative. If you get the product negative, you will get the alternative sign for both x and y. See, let us consider square root of minus I is equal to x plus iy, and if I take squaring on both sides, you will get minus I is equal to x square minus y square plus 2ixy. And here, if you equate real and imaginary parts of 1, you will get x square minus y square is equal to 0, and 2xy is equal to minus 1, or xy is equal to minus 1 by 2. The product is negative here. If the product is negative, we have to choose the values of x and y in such a way that if x is positive, then y is negative. Understand? Minus into plus become minus, that is negative value, and minus into plus become minus. Okay. So in such a way that you have to choose the values of x and y, and the value of x and y should satisfy this equation. So hence we can write x square plus y square whole square as in this form, x square minus y square whole square plus 4, x square y square is equal to, as x square minus y square is equal to 0 from 2, and 2xy is minus 1, and if you write down as 4x square y square as, see, x square y square is obviously minus 1 by 2 whole square, which is 1 by 4, and 4 is here. Then 4 get cancelled here and you are left with 1. Hence, you will get x square plus y square whole square is equal to 1. Therefore, if you make it square root on both sides, you will get x square plus y square is equal to 1. And from equation 2, I can able to write 2y square is equal to 1 and y is equal to plus or minus 1 by square root of 2. And similarly for x, 2x square is equal to 1 and x is equal to plus or minus 1 by root 2. Hence, from equation 3 suggests, equation 3 is this one, that is xy is equal to minus 1 by 2. So equation 3 suggests that we have to choose x and y for opposite signs. You have to choose the value, the sign of x and y in opposite ways. Therefore, the square roots of minus I will be 1 by root 2 minus I by root 2, that is x is positive here and y is negative as minus 1 by root 2, and here x is negative and y is positive. So we have chosen the values of x and y in alternative signs. And also, what is that, x square minus y square is equal to 0. This is 2 and this is 3, equation 3, right? We have discussed. See, we have to choose the product here is minus 1 by 2. If the product is minus 1 by 2, the factors can be 1 by root 2 into 1 by root 2 is equal to 1 by 2. If I take negative, okay, this is negative. So now the value of x is minus 1 by root 2 and the value of y is plus 1 by root 2, and this is satisfies in this equation, right? See, if I substitute minus 1 by root 2 whole square minus 1 by root 2 whole square is equal to what? So this and this get cancels, you will get 0, hence that equation is satisfies. In another way of choosing is 1 by root 2 into minus 1 by root 2, which is equal to minus 1 by 2. Hence here we got the square root of a complex number as x is 1 by root 2, y is 1 by root 2. Here x is plus 1 by root 2 and y is minus 1 by root 2. Hence we can have, hence I can write the square root of a given complex number is minus 1 by root 2 plus I root 2, and another one is this one, that is 1 by root 2 minus I by root 2. This is what we have got it here, which is 1 by root 2 here is, and this is here. Okay, this is a short method to find the square root of a complex number. And in the next class, we are going to solve finding square root of a complex number, and that is a we have to choose the problems from the exercise 8.5, and we will do that in the next class. Sai Ram, and thank you.